Let's consider a problem that a train starts moving at 9 a.m. towards west with velocity 50 kilometers per hour. A plane starts flying at 1 p.m. towards west with velocity 300 kilometers per hour. At what time the plane will cross the train? For solving this problem, let's assume that their trajectories are parallel. So if we write the equations, so these are simple straight line equations. For train, it is 200 plus 50 times t over 60. So it refers to the assumption that well, the preference that the t is defined when the plane starts moving. Then for plane, it is 300 times t over 60. So the problem is being solved in minutes. So the strategy is that uh, we set the time t equals 0 at 1 p.m. and increase time by small steps in minutes and compute the S train, distance traveled by train, and S for plane. And we'll define a distance S plane minus train. So if the distance is less than zero, then train is ahead of plane. Otherwise, plane is ahead of train. So we would like to pick up that point. So since due to the time selection, delta t selection, um, we may not be able to exactly pinpoint the time. So let's do that one with a unit step and program it in MATLAB. So I have opened the MATLAB. So I write a new script. This is the online MATLAB. So I write a title, the problem of plane crossing the train. So now CLC and clear, just to eliminate all the previously stored variables. So I have to define a variable s of plane. S of plane has to be defined. So it is 300 times t divided by 60. This field has to be defined, and then S of train. Okay. Well, this facilitates the readability. So this will be like 200 plus 50 times t over 60. So I have to have the input as time. So I define time equals 0. And at this point, at this time, if I do the calculation and get the values, so I have 0, 0 values. So I make a plot of t and s of plane, and I will plot it as the red circle and t and s train. Okay, this is fine, and then plot it as blue dots, and then I write here a command hold on, and then let's do all these calculation again. But before doing that, let's define x limit. The limit of x should be from 0 to say 100. And for y limits, since the distances are from 200, 300, so it will be a higher value. So I take some value, say from 0 to 1000. Okay, and it will hold. Now let's perform these calculations again. So I define for I equals 1 to 100. So 100 time steps. And I define, delta t has to be defined. So, okay, somewhere delta. This is delta for time. So I define as delta equals 1. So for I equals 1 to 100, define a new value for S of plane equals again 300 times t divided by 60. Oh, so t value has to be updated. So what should be the value of t? T is equal to the old value 0 plus delta value. Delta. Okay. So a new value of t has been generated in the loop. And at that t value, we have generated the plane, S for plane. Now S for train would be equal to 200 plus 550 divided by 60 times t. So this will be for train, and I plot it with the same command. A new point will be generated and plotted, and it will hold the frame. And let's write end for this one. So let's save this one and see what comes. And since we have two lines, so I write here legend, and it should be with the option first is for S of plane, and then S of train. So far I didn't provide any condition to check where it has crossed. Let's see what happens in these 100 time steps. I save this one in the directory. Let's say this is plane algorithm. Okay, now it's ready, and this is the command window. Okay, to run this program, I just have to make a click, and there are no errors, and it seems MATLAB is generating a picture for us. Okay, so there is one red line, and there is one blue line and one red line. So I think this has been repeated many times. So I move it here, right? And then again, let's run it again. Okay. So we have one red trajectory, which is for the train, and one, oh no, red for the plane, and it has crossed that one at some point. So just let's make it a bit smaller, the y limit, and then run it again. Okay, so it is there. So it seems that it is going to cross around um, between 40 and 60. So let's try to figure that point. Okay, so MATLAB has also provided the values of x and y where I made the click. Okay, now the condition that we don't need to have many uh, calculations. We can stop where uh, the values are equal. So I write here an if statement. If let's first calculate that one with a variable. I define a variable distance. So distance is equal to S of plane minus S of train. Now, if distance is less than 0, it is less than 0, then then the distance is less than 0. So train is ahead of plane, and else, so it means train train is ahead of plane, and otherwise else print plane is ahead of train. And this is the point. This is the point that we have to preserve. So I preserved the cross point. So over here, I preserve the value of t, and then I ask computer to get get out of the loop and stop doing further calculation. And this is the end of if statement. So let's execute this one. It will print many times. Okay, train plane figure is being generated, and well, MATLAB is busy. Okay, so the point uh, of crossing has been preserved, right? And no further calculations have been performed. It has got out of the loop. Now, since we didn't provide any print statement, so we have to figure that one out from the directly. So this is the beauty of interpreter-like languages, that whatsoever you have generated, you can call it in the command window. After the program has been executed, all variables have been saved. So for example, if I look for I value, so I is 48. If I look for the cross point, so it is 48. And if I look for the S of train at this one, it is 240. And if I look for S of plane, so it will also be 240. So the point of intersection is where the two lines have the same value. It's a common point. So we have got this one. So you can extend this strategy to get the solution of two intersecting curves. And then with the help of matrices and vectors, you can extend this concept to get a solution, and a solution for intersecting curves, and beyond that. But in the real context of numerical calculation, it's a very slow algorithm. There are better algorithms that give you a rapid convergence to the intersecting points, to the intersecting point. So in this demonstration, in summary, I have introduced the concept of plot generation and plotting again and again with the hold on command. On the online version, due to the communication of the data, it has not appeared as an animation. But if you download MATLAB or Octave and run this script, so you will be able to see all that dots and the darts approaching each other. So you will be able to see that one in the dynamic mode, since I have plotted that one point by point. So there is the for loop structure, and also the if construct. We have used the logical decision. So these are the elements of programming that has been introduced during this demonstration. So I now wish to stop the video recording.